Welcome back, class. I hope that the simplifying and simplifying the radical expressions with multiplying yesterday's homework went well. Today we are going to be talking about division. Division. Okay. So as you can probably guess, division is not that much different. Where if we have say a over b in a square root, then it is the same thing as the square root of a over the square root of b. Now, there are some conditions here. A has to be bigger than or equal to 0 because obviously we cannot take the square root of a negative number. But more importantly, b has to be bigger than 0 because we can't divide by 0. So with that, there is one new thing. This is kind of why we're pushing forward a little bit to cover this concept before you move to geometry next year. There is something called rationalizing the denominator. Okay. The biggest thing about quotients with radicals is that we do not want radicals in the denominator. Okay? So I'm going to write this down. It's the process that eliminates the radical from the denominator. Okay. The process that eliminates the radical from the denominator. So, let's see. Do I want to do that? How do they do it in the book? Let me check something really quick. That one. How do they? See, that's silly. We would never do it for that one. How do they do it? Right there, rationals. Yeah, let's do this. Example 2. Simplify the expression rationalize when necessary. You can say when necessary. Okay. So here's our first one. Don't move that up too high. I still want to see that property. Then it's pretty straightforward. Let's focus that too a little bit. Okay, our first one. We're going to do 3. First one. Let's do the square root of 2 over the square root of 3. For the most part, our expressions will appear like this, where there's a square root on the top, the square root on the bottom. Every once in a while, there will be one large square root, like this expression. Okay. So as we take a look at this, the first thing we should notice, there is a square root in our denominator. We do not want that. Okay. So let me just kind of throw this out there. How do you think using an mathematical process that we already know, how do you think we could get rid of this square root of 3 on the bottom? Go ahead and take a second, maybe think about it a little bit. Let's remember what happened yesterday when we multiplied radicals with the same value. Like in the last example yesterday, we did the square root of 5 times the square root of 5 gave us 5. Let's go ahead and try that here. So if I wanted to get rid of that square root of 3, I would have to multiply by the square root of 3. Okay, now we need to keep this expression balanced and equal. So when we rationalize the denominator and we multiply the bottom, what we do to the bottom, we also have to do to the top. So it's not just multiplying by 3 on the bottom. We have to multiply the square root of 3 on the top. It's kind of like when we balance an equation. When we do something to one side, we have to do it to another. Same thing with the fractions. So let's go ahead and simplify this. Square root of 2 times the square root of 3, square root of 6, over square root of 3 times the square root of 3, 3. Huh, look at that. The square root has gone away. This is what it means to rationalize the denominator. So we'll kind of box this in. We'll say rationalizing. Here is one way we can always check our answers. If we take our calculator, if we did the square root of 2 divided by the square root of 3, okay, we have a small decimal there. Let's go ahead and try doing the square root of 6 divided by 3. Now, based on our reasoning with rationalizing the denominator, these should be the same. Take a look at that. It is. So, when we rationalize the denominator, we rationalize the part that has the square root expression in it. Let me explain to you what I mean by that in our next example. B. Let's have 25y cubed, and there's going to be a square root there, divided by z squared with a square root. So I'm actually going to move that bar a little bit higher. Okay. And I guess I'll erase that part so you don't get confused. So it's the square root of 25y cubed over the square root of x squared. Now, notice I say rationalize when necessary. There will be some instances that you will want to simplify the square roots first. Okay? Like here. If we take the square root of z squared, that takes care of my square root. So that will give us z there on the bottom. Remember, I put a line through my z's to distinguish them from 2's. Okay. There's one other thing that I'm going to say once we finish this one. Just came to mind. Now, let's go ahead and break this top apart. Good thing is, 25 is a perfect square. So square root of 25 is 5. Now, that y to the third, 3 divided by 2, that power over root property, gives us 1.5. We don't want to put a decimal in our exponents. It's not good. Let's go ahead and break that y to the third up to y squared times y. Well, now we can break that apart and square root y squared. So we have 5y. That y is coming from right here. Square root of y over z. So we have simplified and then broke apart. Broke apart. Okay. Almost sounds like Bonaparte. All right. So let's go ahead and do one last part here. Oh, this is what I meant to say. I would really appreciate it if you do not write fractions on the same line. Okay? Take 2 lines on your paper when you do the homework. Take 2 lines to write the fraction. I will, so here, I would not want to see that. Okay? That's just, it may save some space, but let me ask you, does this look better? Or that? Do this every time, please. So I'll erase that so that you know that that's not what you're supposed to do. So, okay. So we've got 2 of these done. Now notice we didn't do any rationalizing here. Okay. B, part C. This is our last one. Okay. Then I'll give you a little more homework. Let's have, this is all under a square root, 36a over 2a cubed with a square root. Okay. So we can do some simplifying first. The first thing we can do is take the square root of 36. Okay? So the square root of 36 is 6, right? Now, a divided by a cubed, using our exponent properties, when we divide, we subtract the exponents. So 1 minus 2, 1 minus 3 is going to give us 2 on the bottom. So it's going to be 6 divided by square root of 2a squared. Okay. Now, one thing that is nice here is that the square root of a squared can be simplified into a. So we will have 6 over a times 1, times 1, over the square root of 2. Okay. Well, let's go ahead and rationalize that denominator. What are we going to rationalize it with? Square root of 2. So times square root of 2 on the bottom, square root of 2 on the top. Here we go. So 6 times 1 times square root of 2 is 6 square root of 2 over 2a. All right. Well, we can simplify. 6 divided by 2 is 3. So it's 3 square root of 2 over 8. So I will admit, there are a couple other ways we could do this problem, but this this is just kind of how we decide to do it. There would be at some point the rationalizing that took place right here. Okay, so I will now write. I was talking about what the steps were. I'll write it down. So we simplify. So like we did the square root of 6, got us 36, and we did the exponent property, and I'm gonna put like 1, 2. So once we did that, and like we're obviously kind of simplifying all along the way, then after we did this, we rationalized, and then we reduced. Okay, because we did 6 divided by 2, it gave us 3. So yesterday I gave you 14 through 30 even. Today I'm going to just give you a couple more problems, not as many. I'm going to give you, your homework is 36 through 46 even. And again, this is on page 623. So this homework will be due tomorrow. Let me know if you have any questions, and I can also, if some of this didn't quite make sense, and after explaining it, I haven't been saying this all too often, but I can send you video links to Khan Academy. I think they do a pretty good job of explaining things. So let me know if you have any questions. Hope you have a good rest of your day, and I will talk to you later. Bye.